Okay, guys. I just want to stress on one point that the last example in the previous YouTube, it was the example which has time and frequency, and he's asking to find the velocity that the car can keep without slipping on the curve on a horizontal circle. So it was like in a horizontal circle, okay, with a radius of r, okay, and the object is moving, of course, with a velocity, okay, in that circle, and he's mentioning that it's moving with a revolution or a 2 revolution per second. I just want to review with you these definitions. I would suggest that you read them. This is the frequency. The frequency is given by revolution per seconds, all right, which we also maybe earlier in earlier classes you took it as hertz or 1 per second. Basically, it's revolution per second. So the unit is 1 per second in hertz. And the period, which is the time, okay, which is in seconds, okay, it's 1 over that frequency, okay. And again, the velocity of one rotation, you see, because here we say the number of revolutions. So of one rotation, it is distance. The velocity is distance divided by time. And the distance is the circumference of the circle, because this is where the car is moving. So it is 2 pi times r, which is the radius of the curve, divided by the tau. All right. So if we go back to this example here, that was basically the slide that you need to review before solving this example. So we found the velocity, all right? Now, in the other example, he said we want the force of that revolving ball. So we have the same example. So we have basically a thread here, and then there is a ball moving in a radius of r. Okay, let me ask you one question. Where is the tension force here? Where is the tension force here? I need to tell you something. If you recall in the previous chapter, chapter 4, I say something that in the pulleys, if you recall, the tension of the object, regardless, it's on the surface. Let me just write the surface like that, or this. The pulley, in the pulley system, the tension is always towards the pulley, towards the source that the object is attached to. The same thing here, the tension force is towards the center. I am just mentioning that. It will not help us in this example. It just occurred to my mind and we need it later. All right. So, no need for the pulley basically example right now. I can just remove it all over. Okay. You know what? I can just use the eraser and remove it all in once. Okay, yeah, that's much better. See, I am getting much better in my writing pad and all these things. All right. So let's read the problem. Estimate the force. Estimate the force a person must exert on a string attached to. It's the same problem. It's the same example 5.1. So no need to really repeat it. But the mass of the ball is 0.15 kilogram. This is already converted. And he wants the force that must be exerted, okay, to revolve into a horizontal circle. You see? there is a horizontal circle. So when you are looking at this circle, it's not a vertical. You have to understand this is horizontal. It's just a circle moving, for example, on a table surface, okay? It's a horizontal, it's not vertical. We will come to something called vertical circle, you know, like that, like for example, Abu Dhabi Eye or Dubai Eye or London Eye, whatever. These kind of what we call it in the amusement park, the Ferris wheel. So we are not talking about that now. We are literally talking about horizontal circle of radius of 0.6 meter. The ball makes the same 2 revolution per second. And from here, if you remember, this was F, and we calculate the time, which is half because it's 1/2 seconds. Okay. Ignore, of course, the strength mass. Okay. So the force is simply M-A-R. Where is AR? It's towards the center. So what is the force basically that is keeping this ball in a circular path? It's the centripetal force, right? It's the centripetal force. So what is the centripetal or the radial acceleration? M is equal mv square over r. We have already calculated this v from example 5.1. But yet, even if example 5.1 was not there, we know that it is distance. I don't want you guys just to memorize the things. Just go from the beginning and do the stuff. 2 pi r over t, and this is our r basically. So it's 2 pi times 0.6 divided by half, and the velocity here from the previous example, it was 7.5, I think so, almost meter per second. So we come here and we say Fc is equal the mass, which is 0.15 times 7.5 square over r, which is 0.6. And what is the unit? It's in Newton. All right, guys. So that example is done. Now we will come to another example, which is, let me see, what is the magnitude? Not this one. It is, we're still in the moving in the horizontal circle. Okay. Okay. And now let's solve this example. We are moving, so we have a 0.55 kilogram ball, so we have mass is equal 0.55 kilograms attached to the end of a horizontal cord. Basically, when he say horizontal, it's just to show you that it is revolving into a horizontal circle, okay, not a vertical, it's a horizontal circle. So radius is equal 1.3 meter, and it's a frictionless surface, okay? So it's just moving on a frictionless horizontal surface. Very big difference between, he said, the horizontal surface, and then later he will say vertical one. If the cord will break when the tension exceeds, just a second. If the cord will break when the tension in it exceeds 75 Newton. You remember in the previous example, I mentioned something called the tension force. The tension is towards the center. The tension, this is tension, it's towards the center. So, if the cord for till up to 75 Newton, the cord will stay intact. This cord will break if the tension will increase more than 75. What is the maximum speed the ball can have? Of course, if you try to increase the speed, you know, like when you are revolving, if you try to give more strength and to increase the speed, you could basically break the cord. you could break that rope that you are revolving, right? I think you can make up this in your mind, that if you have here a ball and you are holding it with a rope and you are trying to keep a horizontal circle above your head, and if you increase, you could lose basically the ball in a certain time. So they say, what is the maximum speed the ball can have before the cord can break? Okay. If you will think about it, the only thing we have is the centripetal force, and this centripetal force here is simply our tension force, right? This is the centripetal force, which is equal mv square over r, right? Because we say that the centripetal force is ma radial or air centripetal, which is v square over r. I will not memorize the other equation for velocity, because from here I can say v is equal square root of r, right, ft square root, okay, divided by m. So this is the velocity, the maximum velocity that the ball can have. So it's equal to the square root of 0.55 times 75 Newton divided by 1.3. No, I did something wrong here, guys. Yeah, I did something wrong. 1 minute. I hope you are following me and you know what I did wrong. This is the mass and this is the radius. Okay, so the radius is 1.3 and the mass is 0.55. So if you plug in the numbers, and I hope you do, it's 13.3 meter per second. It's a very high speed, by the way. So you see, earlier we have an equation for the velocity. Okay, here, where is it? This one, distance divided by time. This is the original one. But you know, from that, the one that's square root of mu s g times r, right? And now we have r ft divided by m. I wouldn't memorize these all formulas. I will just go with the basic thing. For example, here it is the force of tension, and that's the only thing we have. Okay, so it is the centripetal force basically, and from there we can calculate the maximum speed. All right, guys, now I want to start a new topic, which is the banked angle or the banked curve. Just as a reminder, this was the flat one, this is the flat one, and we have figured out what is the maximum speed that we can keep the car negotiating the curve without slipping. All right, and this was all about it. Okay, and now we want, these are all problems, by the way, that you can go through them, and the answers are here. It's about a simple flat curve. Okay, and here we will discuss in the next YouTube about the banked curve, which is a curve that is tilted by an angle. In this the last minute in this YouTube, I will just explain to you that this is not a simple curve. As you can see, it's not a flat. The ground is elevated, and it's elevated by an angle of theta, and that is called the banked angle. And this is our concern. We want to know what is the value of the banked angle. I will see you in the next clip.